Well, natutunan natin sa second part ng ating lecture about liquid-liquid extraction that LLE is based on the difference in solubility. That is why, kung natatandaan ninyo itong picture natin dito, yung original feed natin containing the solute, once in contact with our extract solvent, and after mixing and reaching equilibrium, some of the solute will be transferred or distributed sa ating extract solvent. Well, natutunan natin na mahalaga yung pagkuha ng tamang solvent in order for the liquid-liquid extraction to proceed. So, ipinakita natin sa previous lecture natin kung ano-ano yung mga factors na kino-consider in choosing the right extract solvent para sa ating process. And one of the important factors itong tinatawag nating distribution or partition coefficient. It is the ratio of the concentration of a substance in one medium or phase, which is solvent 1, to the concentration in a second phase, solvent 2, when the two concentration are at equilibrium. So, sinasabi rito na yung ating distribution coefficient is equal sa concentration ng ating solute in liquid 1 over the concentration of the solute in liquid 2. Now, ang pagkuha ng data nito is experimental, but it can be estimated by taking the solubility instead. Okay, so solubility So that's what we mean by distribution coefficient. So using the distribution coefficient, makikita na kagad natin kung possible ba na mag-proceed yung liquid-liquid extraction. Because as you can see, for example, meron kang K which is equal to 2. So 2 is equal to the solubility of A of the solute in liquid 1 over the solubility of the solute in liquid 2. So from here, makikita ninyo yung ratio niya. Using that, okay, 2 times the solubility of the solute in liquid 2 is equal to the solubility of the solute in liquid 1. So from here guys, makikita ninyo na yung solubility ng solute natin in liquid 1 is twice sa solubility sa liquid 2. So makikita na kagad natin dito kung magpo-proceed ba yun liquid-liquid extraction sa pamamagitan ng data ng distribution or partition coefficient. Now in our handbook guys, we will be using what we call the partition ratio. Partition ratio is the weight fraction of the solute in the extract phase divided by the weight fraction of the solute in the raffinate phase. Well, first, consider natin itong diagram natin dito. Ito na yung madalas natin gagamiting diagram when we start our problem solving. So, from our previous lesson, alam natin na yung feed contains the feed solvent, which is A, and our solute, which is B. And then, it will be in contact with our solvent, which is S. Okay, so once the liquid-liquid extraction takes place, itong ating feed will come out as a raffinate. So, in our raffinate, we will still have our feed solvent and the remaining solute. Now, ito namang ating solvent, after the liquid-liquid extraction, we'll have the solvent S and the solute B. Okay, so kung makikita ninyo, initially wala siyang solute and then nag-transfer yung ibang solute natin from feed to the extract. Now, taking the definition of the partition ratio, it means that our partition ratio is equal to the weight fraction of the solute on our extract phase divided by the weight fraction of the solute in our raffinate phase. Okay, so ito yung gagamitin nating equation, guys. Kasi when we start problem solving sa mga LLE sample problems natin, we will be referring sa data na makukuha natin sa ating handbook. Kaya, we will use this partition ratio na nandito sa handbook natin. Okay, so ano ba yung mass fraction? So, reviewin lang natin, no? Mass fraction, for example, ng B in our raffinate is equal to, so ano ba yung nasa raffinate natin? Ito, no? Meron tayong feed solvent and the solute. So, this is equal to the weight of B in our raffinate over the weight of B in our raffinate plus the weight of our feed solvent A. Okay, so ang mass fraction naman ng B sa ating extract, so nakikita natin dito, no, sa ating extract meron tayong solute B and solvent S. So, okay, so this is equal to the weight of the solute in extract over the weight of the solute in extract plus the weight of our solvent. Okay, so basically guys, ito yung mga gagamitin nating equations. Now, as I said earlier, yung mga data ng partition ratio natin, kukunin natin sa ating handbook. In our 7th edition ng Paris Chemical Engineers Handbook, makikita niyan guys dito sa table 15-5. So, this is the partition ratio natin. And in here, yung feed solvent natin is A, ang solute natin is B, and our extract solvent is S. So, pareho ng ginamit nating variables dito sa ating diagram, no? Para hindi tayo malito. So, dito guys, makikita natin sa first column, yung component B. So, ano yung B natin? That is the solute, di ba? Ito yun. And then, makikita mo dito, merong mga A. Okay, may makikita ka. Value ng A. So, that means, ang A natin is yung feed solvent. So, that means, itong component B natin could be benzene or N-heptane dissolved in cetane. The same way here, yung oleic acid dissolved in cottonseed oil. So, ganun yung guys. So, ito yung feed natin. We have the feed solvent, A, and yung ating solute na B. So, dyan natin makikita yon. Kung halimbawa, ang given natin is oleic acid dissolved in cottonseed oil. So, ito na yon. And what is the extraction solvent? Ito yon, kung anong nasa kanan niya. For example, oleic acid. So, ito yung extraction solvent. So, kapag ayan yung given natin guys, makikita mo na rito yung partition ratio natin. So, yan yung gagamitin na partition ratio when we are solving problems. Now, in our 8th edition, so, sorry, this is 8. Ganyan din na makikita natin guys. So, makikita na ninyo dito yung feed solvent, yung solute, and the extraction solvent. And nandito ang ating partition ratio. But in here, the partition ratio is listed in units of weight percent ng solute. Okay? But take note guys, sa mga succeeding videos natin, ang gagamitin ko is itong table 15-5 ng 7th edition. Not because I don't like the 8th edition, but mas kabisado ko lang kasi gamitin to guys. Para sa akin, ito yung mas madaling gamitin. Bago tayo magpatuloy sa ating discussion, we would like to ask for your support to subscribe to our YouTube channel. Please click on the notification bell para lagi kayong updated sa mga ipopost naming mga video. We also like to invite you to register sa aming website, www.engineers.org. Our website is an online community for Filipino engineers, engineering students, and STEM students. So, solve na natin itong problem natin guys. A beaker contains 145 grams of water and 225 grams of chloroform. And these liquids are immiscible. So, meron tayong dalawang liquid nasa loob ng ating beaker, no? So, sulat natin yung ating beaker. And then, meron tayong dalawang liquid sa loob. Okay, so this is our water, and this is our chloroform. So, given yung mass ng water, which is equal to 145 grams, and given din yung mass ng chloroform, which is equal to 225 grams. Then, suppose 55 grams of acetone were added to the beaker. So, nagdagdag tayo dito ng acetone, which is C3H6O, and given din yung mass niya. So, ang mass ng acetone is equal to 55 grams. And then, it was mixed and allowed to equilibrate. Now, how many grams of acetone are in our chloroform? Okay, so ang tinatanong sa atin guys dito is kung gaano karaming acetone ang naandito ngayon sa ating chloroform. So, ang required natin dito is yung mass ng ating acetone na naandito sa chloroform. Well, para hindi masyadong mahaba guys, I will assign this to M1. And then, alam natin guys na itong amount na to ng ating acetone will be distributed both sa water and dito sa ating chloroform. So, since itong hinahanap natin, yung gaano karami ba ang napunta sa chloroform, dapat makuha din natin kung gaano karami yung napunta dito sa water. So, we also need to know what is the mass of the acetone in water. And I will call this M2. Okay, so, i-balance natin yung acetone natin, guys. So, we know that M1 plus M2 is equal to 55 grams. Okay, so, M1 plus M2 is equal to 55 grams. So, ang pinahanap sa atin is yung M1 guys. Yan yung required natin. Okay? Okay, now, given din yung ating distribution coefficient, which is equal to 1.72. And this is the mass fraction of our solute, which is yung acetone natin, in our chloroform over the mass fraction in water. Okay, so isulat natin yan in mass fraction, no, para ma-solve na natin siya. So we have here 1.72 is equal to yung mass fraction natin ng ating solute sa ating chloroform. We have here M1 over M1 plus yung mass ng chloroform over M2, ito yung sa water, over M2 plus mass ng water. And now, substitute natin tong weight ng water at saka yung weight ng chloroform because those are given values, no? So, we have 1.72 is equal to M1 over M1 plus 225 over M2 over M2 plus 145. Ngayon guys, i-simplify natin yung ating equation. Because we need to solve for M1, diba? So, simplify muna natin siya. So, we'll have here M1 over M1 plus 225 times M2 plus 145 over M2 is equal to 1.72. Okay, so nasimplify na natin, no? Kaya lang, ang unknown natin is dalawa. So, kailangan nating makuha yung M1, yan yung ating required. Pero meron tayo ditong initial equation na nakuha, no? So, we can use this equation right here. From that, we know that M2 is equal to 55 minus M1. So, substitute natin itong value ng M2 natin dito. So, 55 minus M1. So, we'll have here m1 over m1 plus 225 times 55 minus m1 plus 145 over yung ating m2, 55 minus m1. And this is equal to 1.72. Now, solving this further, we'll have m1 over m1 plus 225 times 55 plus 145, we'll have 200 minus m1 over 55 minus m1. And this is equal to 1.72. Okay, so multiply natin yung numerator and multiply din natin yung denominator. So we'll have here m1 times 200 minus m1 over m1 plus 225 times 55 minus m1 is equal to 1.72. Okay, so this will be equal to 200 m1 minus m1 squared over 55 m1 plus 225 times 55, which is 12,375, and then negative m1 times m1 is equal to minus m1 squared, and then we have minus 225 m1, and this is equal to 1.72. And then, i-multiply natin yung both side with this value. So, we will have here 200 m1 minus m1 squared is equal to 1.72 times 55 m1 plus 12,375 minus m1 squared minus 225 m1. So, distribute natin to. We'll have 200 m1 minus m1 squared is equal to 1.72 times 55. This is equal to 94.6 m1 plus 1.72 times 12,375. This is equal to 21,285. Then minus 1.72 m1 squared minus 1.72 times 225, 387 m1. Okay, so combining like terms tayo ngayon, guys. We will combine itong m1 squared here and m1 squared sa ating right side ng equation, no? So, daling ko lahat sila sa left side natin. So, we'll have here 1.72 minus 1 is equal to 0.72 m1 squared. And then, combine naman natin lahat ng ating m1. We have 200 m1. Then, we have 94.6 m1. And we have negative 387 m1. So, adding all of that, we'll have here plus 492.4 m1. And then, transpose natin tong 21,000 natin. We'll have here minus 21,285 equal to 0. Okay, guys. So, nakikita natin ngayon dito para ma-solve natin to, we need to use quadratic equation, no? Okay, so review. Ang formula natin ng quadratic equation is equal to negative b plus minus square root of b squared minus 4AC over 2A. Okay? So, substituting these values, we have M1 is equal to negative 492.4 plus minus the square root of 492.4 squared minus 4 times yung A natin, which is 0.72 times negative 21,285 over 2 times 0.72. Now, solving all ng nasa loob ng ating square root sign, we'll have here M1 is equal to negative 492.4 plus and minus 551.143 over 1.44. So, meron tayong dalawang sagot dito, no? We have positive and negative kasi. So, we'll try the positive first. We'll have here M1 is equal to negative 492.4 plus 551.143 over 1.44. So, in here, M1 is equal to 40.793 grams. Okay? So, I will box this. And then, yung ating subtraction, we'll have here M1 is equal to negative 492.4 minus 551.143 over 1.44. So, in here, we'll have M1 is equal to negative 724.68 grams, which is not possible because ang pinag-usapan natin weight, then we have negative sign here. So, that means our answer will be this one. Well, that's it for now, guys, and thank you for watching. We are inviting you to register sa www.engineers.org. It is a community of Filipino engineers, engineering students, and STEM students. Thank you very much and have a nice day.